Hello everyone. In continuation of our discussion on electricity, today we are going to see parallel combination of resistors. As usual, we have a question here. After understanding the concept, we'll try to solve this question. The question is, resistors 5 ohm, 10 ohm, 30 ohm are connected in parallel across the battery of 12 volt. Calculate total resistance of the circuit, total current passing through the circuit, and the amount of current passing through each resistor. I have already made videos on Ohm's law, series connection, the properties of resistance, etc. Links are given in the description section. You can watch them too. So let us go ahead in our today's discussion. So in today's discussion, we are going to connect the resistors in parallel combination. So let us take 3 resistors just as an example. So these are our 3 resistors having resistances equal to R1, R2, R3. So let us name the terminals as we did earlier. So the one which is on the left side, let me call it as a head, and the one which is at the right side, let me call it as tail. So for R1, head 1, tail 1, R2, H2, head 2, T2, tail 2, R3, H3, head 3, T3, tail 3. So how are we going to connect these resistors? So what we do is, we will keep the resistors in such a way that we'll connect all the heads together. We'll connect all the heads together. We are going to connect all the heads together by using connecting wires, and also we'll connect all the tails together. Using connecting wires. So the first one, R1, this terminal H1, T1, R2, H2, T2, R3, H3, T3, and so this is the terminals. These 2 terminals will place across the source. So let's take a battery of V voltage, a switch. So this combination of resistors is called a parallel connection. This combination is called a parallel connection. So in parallel connection, all the heads are connected at one point, all the tails are connected at one point, right? And these terminals are connected across the potential source, volt battery. So this is the parallel connection of resistors. So let us see what would happen since the switch is on in on condition. So what would happen? Current will flow through the circuit. So current I is coming out of the battery. So current I is flowing through here. Now at this point, the current I has, the same current I has 3 paths. Now this current I has 3 paths. Say path 1, that is R1, path 2, that is R2, path 3, R3. So now the since current has 3 paths, so what would happen? Current will divide between 3 paths. So let us call the current through path 1 as I1, path 2 I2, and path 3 I3. So current gets divided at this junction. Currents get divided at this junction. So current division is a characteristic of parallel connection. So what happens here? Current division is characteristics of parallel connection, right? So I1 current flows through R1, I2 current flows through R2, I3 current flows through R3. Now the same currents will again recombine at this juncture. So let us call this juncture as A and this one as B. right? So this is I1, I2, I3. All the three will combine, and how much current is going to flow here? Again the same current I. Again the same current I, hence the circuit is complete. Hence the circuit is complete. So by seeing itself, you are understanding that current division is taking place in parallel connection. Okay. In series connection, in the previous video, you have seen that the same current passes through all resistors. Now here the current is passing through them are different. I1, I2, I3. I1, I2, I3. Now let's talk about the potential difference across each ends of the conductor. So potential difference across each ends of a conductor R1, right, R2, R3. So these are the ends H1, T1. They all are connected at one point. That means this whole potential is going to be same. The whole potential is going to be same, and this whole potential which is going to be same is equal to the potential difference created by our battery. So what is the potential across? R1 V, R2 V, R3 V, and what is that potential created? Who has created that potential? That has been created by our battery source. So voltage across all the resistors remain same. So in parallel connection, potential difference across each resistor, potential difference across each resistor remains same. Current divides, potential difference remains same. Potential difference remains same. So these are the characteristics of parallel connection. Now see that what does our Ohm's law says? Ohm's law says that potential difference is directly proportional to current passing through the conductor, and we can also write it as V is equal to Ri. So by using this, when I know the potential difference across each resistor, which is V, can I write the value of I1? So what is the value of I from this formula? I is equal to V by R. So what is the formula of I1? I1 is equal to V is going to be same, that is V, voltage is V, and the resistance R1. I2 V by R2. I3 V by R3. What do you see here? The three values I1, I2, I3, since the potential difference is same, is dependent upon the resistors, or you can say I is inversely proportional to resistance. So you may see this. If the resistance is more, if the value of resistance is more, then what will happen? Current flowing through that terminal will be less. If the resistance is less, then current flowing through that terminal, that resistor will be more. So is I1, I2, the values of I1, I2, I3 is dependent completely upon the resistors. What would happen if all the resistors are same? If all the resistors are same, then all the currents are going to be same, and equal current flows through each resistors. That is the case when R1, R2 and R3 are same. If they are not same, then I1, I2, I3 are not same. Now if you see here, the current passing through the circuit is I, and at the juncture A, it is getting divided into I1, I2, I3, and at the junction B, they are combining and forming I. So can I write this term like this? Can I write this term like this? That is, the whole current I is equal to I1 plus I2 plus I3. I1 plus I2 plus I3, because the sum of I1, I2, I3 will be I. I is at a junction A, it is getting divided into the three currents. What is the value of I? What is I here? I is the equivalent resistance of this combination. I is the current passing through the equivalent combination of this resistance when the potential difference is V. So I equal to, can I write it as V by R equivalent. I am writing I as V by R equivalent. So this is total current I. Total current I. V is potential difference across the combination. R equivalent is the effective resistance of the combination. Here it is parallel connection. So let's put the values of I1, I2, I3. So I is equal to, I1 is how much? V by R1. I2 is how much? V by R2. I3 is how much? V by R3. Right? So we have written the values of I1, I2, I3. Now here, can I write I as V by R equivalent? So I am writing I as V by R equivalent. So I is written as V by R equivalent. Here, what is on the right hand side? V by R1, V by R2, V by R3. So when I see V is common in the numerator, let's take V as common. So I am left with 1 by R1 plus 1 by R2 plus 1 by R3. So this is so V by R equivalent is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. So V is common. So 1 by R equivalent is equal to 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula for parallel connection. What does this mean? The reciprocal of equivalent resistance is equal to sum of individual reciprocals of each resistance. Okay, the reciprocal of the equivalent resistance, that is the resistance of this combination, is equal to sum of the reciprocals of each individual resistance. Suppose I have n resistors. Suppose here I have n number of resistors connected in parallel. If n number of resistors are connected in parallel, then what would be the formula? Connected in parallel. So what would be the formula? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on up to 1 by Rn. Clear? So this is the formula for equivalent resistance of the resistors connected in parallel. So I hope you have understood the concept. Now we can do the question. So let's see the question here. So what is the question? Let me write the formula first. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 and so on up to 1 by Rn. So this is the formula for equivalent resistance. So what is here? 5 ohm, 10 ohm and 30 ohm are connected in parallel. So let us connect them. This is 5 ohm, this is 10 ohm and this is 30 ohm. So when they are connected in parallel, how do they look? So all the terminals here are connected with connecting wires to one end, and all the terminals here are connected together. Then they are connected across how many volts battery? 12 volts battery. Let me make a switch here, right? So we need to calculate the total resistance of the circuit. So total resistance of the circuit means the effective resistance of the combination. So how much current will flow through it? I current will flow through it. So what would be the effective resistance? By using this formula, 1 by R equivalent is equal to 1 by 5 plus 1 by 10 plus 1 by 30. So what would be we need a common denominator, hence we need to take the LCM. What would be the LCM? 30. So 5 6s are 10, 3s are 30, 1s are. So this is equal to 10 by 30. So R equivalent is equal to, see, this is value of 1 by R equivalent, right? The reciprocal of equivalent resistance. So equivalent resistance equal to reciprocal of this R equivalent is equal to 30 by 10, which is equal to 3 ohm. Please understand here. See, each resistor is 5 ohm, 10 ohm, 30 ohm, but the equivalent resistance is less than all the three. The equivalent resistance is smaller than all the three resistances. Just to see that. So first answer we got answer for A. The total resistance of the circuit or the equivalent resistance is 3 ohms. So this is answer for A. What is our next question? The total current passing through the circuit. So what is this total current passing through the circuit? The total current passing through the circuit will be equal to, how to do that? So what is the potential difference across them? V, which is created by the battery, right? So from Ohm's law we can write I is equal to VR. So V is equal to IR, hence I is equal to V by R. So what is the potential difference created by the battery? 12 volts. What is the equivalent resistance? This will become equivalent resistance because we want the current through the circuit. So R will become equivalent resistance. V will become potential difference across the ends of the combination. So V is equal to IR, it is 12 volts. R equivalent is 3 ohms. So 3 ones are 3 4s are. So the current passing through the circuit is 4 ampere. So 4 ampere current is passing through the circuit. Now the third one, current through each resistor. We'll find out current through each resistor. So resistance 5 ohm, current through 10 ohm and current through 30 ohm. So let's try to understand that. So this 4 ampere is answer for B. 4 ampere is answer for B. So let's do for the third part. Let's do for the third part. What is the total current? 4 amperes. So 4 amperes gets divided as I1, I2, I3, right? I1, I2, I3. So I1 is how much? I1 is equal to potential difference across 5 ohm. Potential difference across 5 ohm. So I am writing it as V5 ohm and resistance 5 ohm. I is equal to V by R. So we want I1, that means potential difference across 5 ohm and potential difference divided by resistance of 5 ohm. So this is it. So what sorry. So what is the potential across 5 ohm? It is same as across the combination, which is created by whom? That is created by the battery source. So 12 by 5. How much is 12 by 5? 2.4 amps. 2.4 amps. Now I2, similarly I2 will be voltage across 10 ohms divided by the resistance of 10 ohms, that is 10. So this is going to be voltage is same, right? For parallel connection, 12 by 10, 1.2 amps. For I3 I am solving it for C part. This is for C part. I3 is equal to voltage across 30 divided by resistance of 30 ohms. So this is equal to, what is the current? Voltage 12 divided by 30. So 3 tens are 3 4s are. So this is equal to 0.4 amps. So this is equal to 0.4 amps. So these are the individual currents I1, I2, I3. if you have done the calculations correct, if you take the sum of I1, I2, I3, then it would be equal to 4 amps, which is the current passing through the circuit. So let's do that. I1 plus I2 plus I3. This is for just checking, no need to do, just checking whether we have done right or not. So 2.4 plus 1.2 plus 0.4, how much is this? 4 plus 2 6, 6 plus 4 10, 1 plus 2 3 4, so it is 4 amps. That is the total current I through passing through the circuit. I hope that you have understood the concept, and now you can do the questions on parallel connection. In the next video, we'll be talking about the combination of both parallel as well as series connection, how to find out the resistors are connected in series or parallel in those circuits. The links for the other videos will be in the description. Please watch them. Thank you.